Quadratic formula. So we're going to use the quadratic formula as another means of helping us find the x-intercepts or the roots of your parabola. Okay. So if here's our parabola, this will help us find the roots of the parabola. Not everything will factor perfectly, so when something doesn't factor perfectly, we can resort to the quadratic formula to find our roots. When in doubt, always use the quadratic formula. Okay. So let's look at our quadratic formula. This is the formula: x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. Make sure the b, when you divide by 2a, it includes the b. All right, common mistake is a lot of students just put the 2a over the square root. The 2a is over the entire expression. All right, so negative b plus or minus square root of b squared minus 4ac all over 2a. I'll show you the next couple minutes what the plus or minus means, how it applies over 2a. Where are we getting these terms from? A, b, and c. We have our trinomial here, ax squared plus bx plus c. Okay, so your leading coefficient, the coefficient in front of your x squared is your a. The coefficient in front of your x is your b. The coefficient in front of, or your last coefficient is c. All right. So let's take a look at an example. Before we actually get to an example, this portion of your square root, okay, this portion of your quadratic formula, b squared minus 4ac. This portion right here is called your discriminant. Okay? The discriminant will tell you something about the roots of your trinomial. Three things can happen. One, when you solve this and you have the square root of b squared minus 4ac equals 0, this means you'll have one real root. Meaning, on your graph, your parabola will touch your graph at one point. Okay, the bottom of your parabola will touch your graph at one point, or one coordinate, so that's one root. Second option here is if the discriminant is greater than 0, you'll have two real roots. Meaning, if you have your graph and you have your parabola will cross the x-axis at two different coordinates, creating two roots, two real roots. And lastly, if the discriminant is less than 0, then you have something, the roots are not real, they're called imaginary roots, and I'll leave that for Algebra 2 when you get there. Okay? So for now, in Algebra 1, we're going to say if the discriminant is less than 0, the answer will be no solution. Which really just means you don't have any real roots. Okay, so let's take a look at our first example. X squared plus 4x plus 3 equals 0. So we're going to use this to solve for roots. I like to just put the formula on top sometimes, ax squared plus bx plus c, just until you get used to it. Make a list of what your a, b, and c are. A equals, what's my a? 1. B, what's my b? 4. And what's my c?
3.
Okay. So before I start, I'm going to see what the discriminant is. So if I ask you how many real roots, or how many roots will you have any real roots or imaginary roots? Let's see. So what's my formula? X equals negative b plus or minus square root b squared minus 4ac all over 2a. I'm going to ask that you write this formula out before every problem until you have it memorized. So if I plug in, I'm going to say x equals negative b. So we have negative 4. Be careful. This negative sign in front of the b is separate from a negative sign in front of the coefficient. All right, so make sure they're separated. So if this was negative 4, this would be negative 4. All right, plus or minus b squared. So I got 4 squared minus 4 times 1 times 3 all over 2 times 1. Substitute in first. All right, so the next piece here is just computation. X equals -4 plus or minus square root. What's 4 squared? 16 minus. Okay, so when I do this part, I like to look at this part in its entirety. So forget about the 4 squared here. So I have -4 times 1 times 3. -4 times +1 times +3. What is that? -12. So there's my -12 over 2. Simplify again. -4 plus or minus 16 minus 12, square root of over 2. Keep going down. Equals -4 plus or minus square root of 4 is 2 over 2. This is where you break it up. Okay, this is where you get two different answers. So you're going to say -4 plus 2 over 2, or your second option is going to be -4 minus 2 over 2. What's -4 plus 2 over 2? -4 plus 2
-2
over 2. So x equals -1, or -4 minus 2, -6 over 2, and you get, so your two roots are going to be at -1, -3. So again, if we're going on our graph here, your two roots will be here at -1 and -3. That's where your parabola will cross your x-axis. X squared plus 2m plus 1 equals 0. Alright, so I'm going to use my quadratic formula again. I would recommend writing it down as often as you can, just until you memorize it. I'm going to cheat a little bit and steal it from this problem. So we got x squared, or x equals -b plus or minus square root of b squared minus 4ac all over 2a. Make myself a list. What is my a? What is my b? What is my c? What's my a?
1
1. What's my b?
2
What's my c? Beautiful. Plug in. X equals -b. I'm sorry. X equals -2 plus or minus square root of b squared, just 2 squared, minus 4 times a times c. That one works out nicely for us. All over 2 times a. Substitute and solve. -2 plus or minus. If you could do this whole piece mentally in one shot, go ahead. 0, so you're going to get the square root of 0 all over 2. What is the square root of 0? 0. If the discriminant is 0, what does that tell you about my graph? One real root, okay? So when you're graphing this, you're going to have just one root. It's just going to touch the axis here. It's not going to cross below the axis. It's just going to touch it. All right, so this becomes -2 plus or that goes away. -2 over 2. And -2 over 2 is -1. So x equals -1. So your root is at -1. So this graph actually should be here at -1. Okay, so your discriminant is equal to 0, one real root. Alright, so next example, 3x squared plus 6x plus 12 equals 0, using my quadratic formula. A here is 3, B is 6, C is 12. Alright, plug in, x equals -6 plus or minus square root of 6 squared minus 4 times A times C all over 2 times A. -6 plus or minus, simplify my square root. So I have 36 minus -4 times 3 times 12. I get 144 all over 6. So if we pay attention inside my discriminant right now, what's 36 minus 144? Is that going to yield me a positive answer? No, so my discriminant is going to be negative here. So what does that tell you about this quadratic or this factor? There'll be no solution right now, or it doesn't have any real roots. The roots are going to be imaginary. Alright, so for now, for Algebra 1, we're going to stop here and we're going to say no solution. Okay, so if your discriminant is going to be less than 0, you have no solution or no real roots. Alright, in Algebra 2, they'll teach you how to find your imaginary roots and actually how to graph them as well. Alright, our next example. So 2x squared plus 9x minus 5. Our next example. Let's plug this in. So are my A, my B, my C. My A is 2, my B is 9, my C is negative 5. X equals negative 9 plus or minus B squared, which is 9 squared, minus 4 times 2 times negative 5 all over 2 times 2. Simplify. This is going to be negative 9 plus or minus square root of 81. Alright, so again, when you look at this piece here, look at this all together. So you have negative 4 times 2 times negative 5. Negative 4 times 2 is negative 8. Negative 8 times negative 5 is negative 8 times negative 5 is positive 40 all over 4. Simplify this again. I'm going to bring it down here. Negative 9 plus 81 plus 40, 121 over 4. That worked out very nicely for us. Negative 9 plus or minus square root of 121, 11 over 4. Okay, so this is where you split it. So you have two options here. First option, negative 9 plus 11 over 4 equals something. Or your second option is negative 9 minus 11 over 4. So again, that's where your plus or minus comes into play. Negative 9 plus 11 is 2. 2 over 4 is 1/2. Negative 9 minus 11 is negative 20. Negative 20 divided by 4 is negative 5. So my roots here are x equals 1/2 or x equals negative 5. Okay, so the next example. So 5x squared plus 2x equals 5. Okay, first off, everything should be set to equal to 0. So we should rearrange this and say 5x squared plus 2x minus 5 equals 0, just bringing the 5 over to the other side. Alright, so be careful there. Otherwise, you're going to put your C as a positive 5. So A equals 5, B equals 2, and C equals negative 5. One more time, quadratic formula. Negative B plus or minus square root of B squared minus 4AC all over 2A. X equals negative 2 plus or minus 2 squared minus 4 times 5 times negative 5 all over 2 times 5. Keep reducing or keep simplifying. Negative 2 plus or minus square root of 4 plus 200 over 10. 200, 5 times 5 is 25. I'm sorry, 100. 5 times 5 is 25. 25 times 4 is 100 equals reduce again. Negative 2 plus or minus square root of 104 over 10. Okay, so here's the question. What happens if the square root is not a perfect square? Okay, let's do it on the side here. Just going to say, what is the square root of 104? We want to break this up into two factors. All right, so you want a factor that could be, that you can take the square root of it perfectly. What's a factor of 104 that you can take the square root perfectly?
4 and...
So 4 times...
6, 426.
4 and 26, okay? So 4 times 26 is 104. What is the square root of 4? So that goes away. So 2 comes on the outside. What is the square root of 26? Can't take the square root of 26, so leave it as 26. So this part here becomes negative 2 plus or minus 2 radical 26 over 10. One more quick little simplifying. You have 3 terms. You have 1, 2, and 3 terms. If they all 3 of these terms have something in common, then reduce. 2, 2, and 10 all have a 2 in common. So if I divide each one of these by 2, I get negative 1 plus or minus 1 radical 26, or just radical 26, over 5.